Activation energy is required in a chemical reaction. In a chemical reaction, the substances on the left-hand side of the equations are called substrates or reactant. Those on the right-hand side are called products. To have chemical reactions, there must be effective collisions among the substrates. You can see the animation on the right-hand side. When A collides with BC, if the collision is effective, BC will be broken down and A will link up with B, leaving C alone. To kickstart the reaction, we must first of all provide enough energy to the molecule A so that there will be a powerful collision to make the new products. Now, what happens if the energy supply is not enough? Now, you will see the animation. If the initial energy is not enough, the collision is not effective. And although there is collision, no chemical reaction can take place. The other condition is orientation. You see from the animation. When we change the direction or the orientation, A will collide with BC with the wrong orientation. Then no reaction can take place. So in order to have chemical reaction to take place, the collision must be effective. That means we must first of all supply enough energy. Also, we must have A collide with B with correct orientation. So what is activation energy? Activation energy is the energy required for a reaction to start. When you kickstart a reaction, you must supply enough energy so that there will be an effective collision to take place. So you can refer to your notes. There is a graph as an example. Suppose I have some glucose. You know that glucose is energy rich. When you burn the glucose, it will change to CO2 and H2O. Both CO2 and H2O, they have low energy level. If you put the glucose in room temperature, it will not spontaneously change to CO2 or H2O. You must supply certain amount of energy. For example, you burn the glucose to high temperature, then the glucose will change to CO2 and H2O. So the energy supply to make this reaction possible is called activation energy. As a revision, this is a catabolism because you break complex molecule into simple molecules. Note that energy is released from this reaction because glucose is of high energy level and the resulting product is of low energy level. 由高能變低能，所以能量係釋放出嚟嘅。In catabolism, energy is released. Another example of anabolism. Anabolism is linking small molecules together to form complex molecules. In this case, we have the CO2, H2O, which are of low energy level. They will change to glucose, which are of high energy level. So for the reaction to take place, we must supply enough energy to kickstart the reaction. This initial energy supplied to the reaction is called activation energy. Note that the energy level increase when it changes from CO2 and H2O. So in this case, anabolism must absorb energy, absorb this amount of energy. Here, I need to explain another important chemistry term to you, catalyst. What is a catalyst? It is a substance that speeds up, accelerates a chemical reaction. For example, if I have a chemical reaction, H2O2, we have H2O is water. H2O2, we have 2 oxygen, so we call it 雙氧水 in Cantonese. This one in English is hydrogen peroxide. When the hydrogen peroxide, you put it in room temperature, it will slowly broken down to form water and oxygen. So if you buy a bottle of hydrogen peroxide, maybe after 10 years all of them will be broken down to water and oxygen. 10 years is a very long time. How can I make it faster? We can use something called catalyst. So we can look at an experiment. When some catalyst is put into hydrogen peroxide breaks down to form water and oxygen. Heat is also produced, so you will see there is an effect of explosion with the gas coming out together with the water vapor. So what's the difference between a chemical reaction with catalyst or without a catalyst? You see from this diagram as an analogy. With catalyst, it will provide a shorter pathway, which is an easier pathway for the substrate AB to become the product. Without catalyst, you will see that the pathway is much longer, which required more energy for the reaction to complete. So you can also look at the graph in the notes. Here we have the graph of a reaction with a catalyst and also without a catalyst. What are the differences? You will see this one is called activation energy, which is the energy to kickstart a reaction. With catalyst, you will see that the amount of activation energy is much lower than the one without a catalyst. You can refer to this animation. This figure represents the catalyst. A catalyst provides another pathway for the reaction to take place. This pathway has a lower activation energy. Enzyme is a protein molecule which acts as a biological catalyst. It works by lowering the activation energy to speed up the chemical reaction.
In the course of most reactions, an unstable and highly energetic transition state is formed as the substrates are transformed into products. An enzyme acts as a template for the reaction, binding to its substrate and holding it in the proper position to form the product. An enzyme also surrounds its substrate with reactive groups that stabilize the transition state, making it easier for the reaction to occur.
To summarize, activation energy is required to kickstart a reaction. In order for the reaction to take place, you have to overcome the energy barrier, and then the reaction will take place spontaneously. With catalyst, we can provide another pathway for the reaction to take place, and this pathway has lower activation energy. Enzyme is a kind of biological catalyst. Hope you enjoyed this video. Goodbye.